So, we continue from what we were doing in the last class. We were talking about how to get an hang on the option price at any time t for any stock price as t. So, we will start to see what should I do when I get the premium, because I had been taking the role of the person who has sold the option, and you, the viewer, is the person who has bought the option from me. So, such an option is called a call option, where you are buying the option, not selling the option. So, now what I would do, let this is delta t be the number of shares I am holding at time t. So, this is the number of shares I am buying of the stock that I have. There is one stock in the market and one bond, one bank, basically bank account. So, number of shares of the stock held at time t. So, if ST is the cost of one stock at time t, one share of the stock, then total worth of my stocks is delta t ST, is the total worth of my stock. If I sell the stock at that time, this is what I will get. So, my portfolio value, so suppose now you have at time t I have xt amount of money, and I now buy delta t amount of stocks paying delta t st money. So, this is the amount of money I have left. So, so at time t, suppose I had xt amount of money, I bought this amount of stocks, shares of delta t shares I bought of the stock, each share costing st. So, this is the amount and this is the amount left, and this is the amount I am going to send in the bank. So, this amount goes to the bank, goes to the fixed deposit, say fixed deposit or money market. Also, this language is used in finance. Now, at time t, once I have invested, how much would be my interest rate, right? From the interest I would have the following earning. So, on this amount of money, this is the amount of interest I have been given. At time t, this is exactly the amount of interest I will have, because that is the, when he is calculating the interest from time 0. So, at time t, this is the exact amount of interest I will have. This is the amount of interest I will have. Of course, if I take back the money, then I have this plus this, but just the interest I have is this. So, I am just taking the interest. So, basically what is my xt? Xt consists of this plus this. So, at any time xt is nothing but my any time my xt should consist of how much money I have spent for the stocks plus, or at basically, see, the idea is this: I am buying, selling instantaneously. I am selling and buying at this very moment, which is a very strange thing, does not happen, but the time interval could be very small, so that you can take it almost at the same time. So, basically I am holding the thing for a very short time. So, I have employed this money, and after that the very same time I am taking back the interest on that money and selling the stock that I had held. So, then I sell the stocks at this and get this amount of money, plus I add this money which I get from the interest. So, this is a very strange idea that you have instantaneous selling buying. Instantaneous selling buying does not happen in a market. You could sell now, buy now and sell after 2 minutes, but we assume that the gap is so small that is what you are doing, instantaneous selling and buying. So, these things take time to seep in. So, when you do the finance course, gradually you will see that why we are talking, why the model is, and we will do it very slowly. I think I will plan a much longer course, we will do it slowly. So, then you have a better idea of the financial aspect. I am not talking about the financial aspect at this moment, I am just telling that that is what can happen. So, if you write the differential of this whole thing, then what is this? This is delta t dst plus r into xt minus delta t st into dt. That is the differential of the stock price, because xt, right, xt itself is so you are writing the differential in that form basically. So, at time dt, what is the change in the interest price? At unit time, the change in the interest price is this. At time dt, the change is at this into dt. It might not be so easy to understand this unless we have seen discrete time analysis of the financial market. That will be done in the next course. Discrete time is, now you are at time 0, at time 1 the price could either go up or go down. If it goes up, from there it can again go up or go down like this. It is a binomial tree. So, here, 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 then here, here, just like this. And actually from there you could actually get a lot of ideas. So, unless you do that binomial studies, it is not really feasible to give anyone a better idea of what actually is happening, but assume that this is the scenario basically. So, then differential of this is given like this. So, this is the amount of interest accumulated at time dt. At every unit time the accumulated interest is r into that, and at time t is, at time dt, del t is the fraction that is accumulated. So, this can be now written as I am opening up the DST actually, which you know, if you have forgotten it, I just make you remind you that DST is alpha ST dt plus sigma ST dWt. Plus, sorry, dt plus delta t sigma ST dWt. So, this is the differential when I open up ST. Now, we would be concerned not with just the portfolio value, but by the portfolio, the discounted portfolio value, because I am taking decision at time 0 about what can happen at earlier times or at later times. So, I want to look at everything from this point of view, current point of view. So, what would be the price of my portfolio now, so that after time say t, the portfolio value is say xt. So, we will look at the discounted portfolio value, or we will also first look at the discounted stock price and write down its differential equation or a stochastic differential form, and then we will also look at the discounted portfolio value. So, basically we are going to look into the differential of this first. In order to do this, we consider the function of the form FTX now we will again apply the Ito's formula. This will be nothing but DFTST, because FT, if you put ST here, it is this, which is FTTST. See again, so again I am applying the Ito's formula. So you will see how Ito's formula is being applied. There is a quadratic variation term. So DST. So you see, you start learning the use of course you can find the quadratic variation term from here. So you know that will be nothing but sigma square S square T dt, and then you analyze the whole thing. When you analyze and put dst here and write down the quadratic variation here, and of course maybe here if you take the first derivative would give you e to the power minus RT with respect to x, the second derivative is 0. So you can basically forget this part and just have this part, and when you write down what is dst from here, you will finally get the following expression, which is alpha minus r e to the power minus RT ST dt plus sigma e to the power minus RT ST TWT. This is what you are going to get. Now once I know that, can I now, because I have ST in this expression, can I now know what is, how my portfolio value is evolving. So both for this and this, the Ito's formula is applied using the same function. Only instead of x, in my case, now when I am looking at the portfolio value, I have to write xt. In the case of stock price, I wrote st. Here xt is my portfolio value. Just if you have portfolio value, so I have a portfolio. My portfolio consists of some shares, number of shares of a given stock, and the amount I put in the fixed deposit. That is my portfolio I am holding at every time t, and I am instantaneously selling buying. That really does not happen. The selling buying happens at various periods, and when the periods become very small, they tend to towards the continuous case. So we all, in mathematics, we always try to look at the limiting case, because that is much more easier to deal with. In real life, there is no such thing. It has to be only done at discrete period. If you do a time after 5 minutes also, it is not really instantaneous. But okay, but for understanding the whole process, continuous things are much more easier to handle. So this is also called the portfolio value. So if I look at this, I will go ahead and apply the same thing, and then you can prove that this is nothing but delta into d of delta t into alpha minus r e to the power minus RT ST plus delta t into sigma e to the power minus RT ST d omega t. So if you look at it very carefully, you take the delta t common outside, and this is nothing but delta t, and if you look at this expression, so there is a beautiful relation between these two differentials. So the differential of the portfolio value is nothing but, of the discounted portfolio value is nothing but the number of shares I am holding into the differential of the discounted stock price. So this is exactly what it is. Okay. Now I have this fact. Now I have to see how my option value is evolving. option price I have already mentioned in the last lecture is a function of the form Ct S of t. Okay. At every time t, that should be the premium you should pay me if you buy the come into the contract at time t. The expiration time capital T remains the same, whether you buy at time 0 or time capital T by 2, does not matter. So this is, so essentially I am going to look at I am going to seek to find a continuous function Ctx, that should be my goal. That will, and of course again I am writing continuous. So what we now do is we now try to see how my option value evolves. So what we have here observed is the evolution of the portfolio value, and then I am going to observe the evolution of the option value. And what I have studied there was evolution of the portfolio value. You might understand that why I am using the Streve's book. Yeah, I could have run it, or if I had to really do it, it would have taken a long time and cannot be covered in the lecture. So I am just picking up certain parts from the book and trying to give you more explanations, right. So this is to explain you more clearly, which cannot be understood if you just for the first time go and read Streve's book. This book needs to be read a lot of times to really understand what is going on. So the idea is this: if I can find the way my option value is evolving, I want my portfolio value and option value should evolve in the same way, then only I can hedge the risk. So then I will equate the differential of these two, and from there I will generate the equation by which C can be obtained. So actually here I am looking at the function Ctx, where x is playing the role of St, right. So x is playing this role of St. So if I look at now, so now again by Ito's formula, so you will immediately understand. So this, so use Ito's formula. So you see, a lot of finance is largely about how good or how well you are able to apply Ito's formula. So if you look at this thing, this is of course Ct, Tst. Ct means of course derivative with respect to t, dt plus Cx, Tst, dst plus half Cxx, Tst, dst, dst. Now you see here you cannot put this is equal to 0 because we do not know the form of the function. That is what we have to find out. We will be led to some second order on a partial differential equations. We really have to find out what is this, what is the C. So we do not know, so we cannot throw away this term. So you have to use the variation, this quadratic variation. So quadratic variation what would be the quadratic variation of this? Sigma square S square t dt. dwt which is dt. So this is the quadratic variation. Essentially, if you want to write it more clearly or in a more proper fashion, this is 0 to t sigma square S square t dt. So instead of, so now if I put all those values, all those things, putting dst and opening up dst, then finally I get a form like this, CT TST plus alpha ST CX TST plus half sigma square S square T CXX T ST, this whole thing times dt, this whole thing into dt. Maybe I should write it slightly on the side so that you get the writing clear. So I will write, so this is now equal to, the same thing is now equal to, so I have now, after all the simplifications are done, just plug in the DST, check at home and put this value here. Plus half sigma square S square T CXX TST d of t. This is the dt part. So, this is the drift part now of this Ito process. Everything is viewed as Ito process, something that has to be remembered. Some sigma ST, sorry, sigma ST CX TST dWt. Okay, that is what you will have. Now, we have essentially spoken about the discounted stock price. See, discounted, the stock price itself is not a martingale, the discounted stock price is a martingale. So, when you take a discounted stock price, you have much more stronger properties of the stock price. You can have more information about it. So, we are always working with discounted stock price, discounted stuff, because we want to know at present what is their current. I am evaluating everything from the present scenario. So, at present what is their value. So, basically now I have to talk about, so I am expecting the stock evolution of the, see the stock and money market evolves in the same way, because the stock, the option price depends on the stock price, it will also evolve in the same rate. The rate at which the stock grows, the option price will vary accordingly. So, we are going to look into so, without getting into again applying now the Ito's formula, with now in this case you take ftx is equal to e to the power minus RT into x, and instead of x you put CTST. This now the formula that you have to use to apply Ito's formula, the f that you have to use is of this form, where x you put CTST. So, basically it is d of f t c t s t, and then if you actually compute the whole thing out, then you will have a very rather very complex looking stuff. Of course, because we are at the end of the course, some complex looking stuff would be a good thing, but no, mathematics is essentially a simple thing, but okay, this has its own thing. So, this is equal to, if you apply the Ito's formula. So, now apply Ito's formula, and then you write the following thing. Sorry, minus R C T S T. So, there will be a dt part. So, I am writing down the dt part. I am not doing these calculations because it will take too much, then it will take the, I think one lecture would go more than 1.5 hours or 2 hours. basically when you do this, you basically use again this formula here to open up the whole thing to get this final form. This thing into dt plus e to the power minus RT into sigma ST Of course, you can ask me what is the real use of sigma. These will come in the finance course where we really talk about these objects in a much more detailed way. Now, what is the key idea? Let us now discuss the key idea. So, we will keep this formula at hand, which is this evolution will not require, we will just remove this. So, we want the portfolio, the evolution of the portfolio value and the evolution of the option value that the, or rather the evolution of the discounted portfolio value and evolution of the discounted option value are the same. Their nature has to be same. So, we can really say that at the end what we want, we need a discounted thing see what we are looking at is the intermediate values from time 0 to time capital T, but capital T is not included there, because at capital T I know what will happen, because the market is complete I will be able to completely hedge, I will be able to have C capital T, S capital T is equal to the max of that. So, it will be exactly equal to x of t. At that time, at time t I know exactly what is happening. So, I do not have to bother about time t. What I want that in between they should behave in a very nice fashion, they should exactly have the same behavior. So, that is some sense telling okay, possibly if they if it has behave, if it has to match at time t, possibly it is a better idea to make them match at every time. So, we need this idea. We need this idea. So, basically I want to equate this, we want to equate with this. How do we do that equation? Of course, you know that x0 is the price that you have, x0 is the amount of money that you had taken in the beginning from, I have taken in the beginning from you, which is this is required. And x of capital T of course should be, and x of capital T should be, and this is already guaranteed by your complete market hypothesis. This has to happen, I should be able to completely hedge, completely offset my risk. That is the main idea. Now, let us do one thing. So, if I start hedging, now if I start equating, so I equate this with this. So, what would I get? I would like to first equate the random part with the random part, the volatility part with the volatility part and the drift part with the drift part. So, if I equate this part with this part, then what I get is, so equating the coefficients of WT on both sides we have what do we have? We have the delta T, we have delta T is equal to Cx TST. So, here I want this to happen for all t element of starting time to capital T. This is already known given to you. So, what do you get? You get this. This is called the delta hedging formula. This is one of the Greeks of the option. It is called the delta hedging formula. So, this formula is called the delta hedging formula. What does it say? It tells you at every time cap T, if you know the option price, I can tell you how much stocks, shares of the stock you have to buy. So, if I differentiate this function and at time 0, I will know what is the starting amount of stock I should buy. So, if I am able to compute the function Ctx or Ctst by differentiating Ctx and putting the appropriate time in, I will know how much stock I need to buy at time t. So, that is why this is a very important formula. This is actually used in practice. This is in, of course, the implementation is slightly different. It is called the delta hedging formula. Now, we this is this Cxt, this thing is sometimes called the delta of the option, because this is the equal. Now, we have to equate this part with this part and e to the power. So, equating the dt parts, the coefficients of dt. So, you know e to the power minus RT will get away from both these sides and you have to equate this part with this part. I am not writing it again in detail because then you can check it out. So, if I do that after doing some manipulations, this part will get cancelled, you see this part will get cancelled with some part use with ST here. You have ST here, e to the power minus RT will be taken off. So, you will write alpha minus RST and alpha minus RST so I am just equating this part, the dt part, sorry, yes, there should be a dt here. Please note there should be a dt here. If I have missed it in the earlier thing, please make it sure. So, I am equating this part, so alpha minus R ST into delta t should be equal to this whole thing. Now, if I do that, so what I would have, but delta t is again equal to Cx t st. So, I can write Cx alpha minus R st into Cx t st is equal to this part, that is equal to minus R Ct Tst plus minus R Ctst plus Ctst. So, that is just the C and then this is the plus alpha St Cx Tst plus half sigma square S square T Cxx, now you have this term Cxx, second order term Cxx Tst. So, we have equated the dt parts by knowing that delta t here is this. So, you have found out delta t using the other one and then you have done this. Now, if you look at very carefully, alpha st cxt here, you also have alpha st cxt here, same thing. So, you can cancel that out and you can take minus r st cxt to that side and keep this the other minus to this side. So, you will have an equation of this form Ct Tst plus R St Cx Tst plus half sigma square A square T Cxx Tst, and this should be true for all t between 0 to capital T. And you know that with the fact and C T S capital T C T X capital T is max of St minus k and 0, because that is exactly the hedging that I have to offset my risk. Now, which means that the option price at every time t can be found by trying to find a continuous function Ctx, where Ctx satisfies the following partial differential equation. St is playing the role of x. So, this is for all t element of 0 to t, this equation must be satisfied, and x must be greater than equal to 0 because the stock price must be non-negative, and there must be a terminal condition which is this, and under the terminal condition, the following, this which is C T x, t is the terminal time, which must be equal to max of x minus k and 0. X is actually your S of capital T. So, this thing, this one is called the Black-Scholes PDE or the Black-Scholes equation. Of course, what is this price? So, we will show in our finance class, finance lectures, that the price at time 0 can be evaluated not just by solving this equation, because solving this equation numerically is a huge piece of research. A lot of work has been done how to solve the Black-Scholes equation. It can be obviously written and converted into a type of heat equation and then tried to solve it, but a lot of work has been done on the numerics of it. But there are other ways to forget the partial differential equation and using the risk neutral idea and doing something called a Girzanov's, using something called a change of measure, going from one type of Brownian motion to the other, using Girzanov's theorem and using basic probability theory, one can actually compute what should be my price at any given time t. Ctx can be computed. So, that can only come in a finance class where lot more information about finance has been given to you. So, it is called the Black-Scholes partial differential equation PDE, and with the, as promised, we have ended our discussion by coming to the Black-Scholes equation, and this ends the course, and hoping that you have enjoyed it. Even if you have not enjoyed it, you have got some information. In a 10-hour course, it is not really just, it is not, one can do too much justice to this huge fascinating subject called PD, it is called Stochastic calculus. You think that you are sitting down there and you are really understanding what is going on? No, because possibly I also do not understand what is really going on. So, you might ask me that this equation is in almost everywhere sense, yes, but this equation when you do it is not really almost everywhere sense, it is the standard PD. So, hope that you have enjoyed it and hope that many of you would join the finance class, but which will be done in a much simpler straightforward way and which will be done in with not coming to these equations, not too much bombarding you with Ito's formula, though Ito's formula would be required in some cases, but essentially giving you the basics of finance, their finance would play a major role, the financial intuition will play a major role, and also you will see how the mathematics can be naturally evolved out of that. That would be the course, but many tools from this course would be required in that course and that will not be repeated here. We will come with the assumption that you have certain understanding. So, with this I thank all of you for being a part of this course and I hope you had enjoyed as I had enjoyed in giving these lectures. Thank you very much.